Okay, everyone. Hi, thank you so much for joining. And we are going to cover a few things today. I will now walk you through everything. We are also recording this session to be made available online for the rest of the participants. So I'm just going to go ahead and start sharing my screen so you can kick it off. Fantastic. So basically, today is our second session, and hopefully you can all see my screen. You can see me. I'll keep admitting people as well as we go along. So if at any point either my audio drops or you can't hear me, please just let me know because otherwise I wouldn't know. Okay, so to get started, this is our second session today. And we want to cover an overview of machine learning models and how to set up a data science pipeline for the UN Datathon. And this is the rest of the series is here also on the screen. The ones in green are super beginner friendly ones, and you can see this whole calendar on the UN Datathon website as well. The ones that are not highlighted in green are ones that need a little bit more pre-preparation, and you need to be following along a little bit for those sessions, and you might need some more background knowledge. And if at any point you have a question, I have set up this Slido as well, which you can just go to and you can post your questions there, and you can interact with others, and you can upvote if they have asked a question that you also were wanting to ask. So just to give you a quick overview, here is the Slido that you should be able to access now. And when you ask a question there, you can anonymously ask it, and you can upvote other people's questions so that I know that, oh, a lot of people are right now thinking about this question. Then we are going to actually begin with a quick poll, just so that I can get a sense of where people are at in their data science and machine learning journey. And that way I can calibrate the content for this session and for upcoming sessions as well. So if you can all kindly hop over to the Slido, I will start putting in some questions for us to basically understand where everybody is at. The first question I just want to ask you guys is, how familiar are you with data science and machine learning? And the way I have basically given the options is you can give two answers, one for your data science expertise and one for your machine learning expertise. Because some people might be really, really strong in data science, but they might not have done machine learning before, or vice versa. So if you could go there, pop, certainly I'll pop the link again. Here's the link for the Slido in the chat again. Awesome. Awesome. We are getting some votes. Okay. So from what I can see so far, as the votes are coming in, it seems that most of the people have a decent kind of data science background, but most of the people are in the early part of their journey for machine learning, which is great. This means the chat today will be super useful for those who are at the earlier part of their journey. Now we'll switch. I will ask a different question because we are in the privacy enhancing technologies track. I also want to understand, have you heard this term around responsible data science? So please just, if you can pop some votes there in the poll as well. What's in the previous answer? Yes, we did. Because you were in the last session, I think your answers are already locked in, so you might not be able to answer again if you were in the session we did on Monday. Amazing. Okay, so it seems like people have some basic knowledge of responsible data science, but it seems it's a fairly new concept for most people. All right. Last question before we jump into the session proper is what is your exposure to privacy enhancing technologies? For people who have joined in the last 5 minutes, I've popped the link to the survey again. Basically, I'm just trying to calibrate where people are in the data science and machine learning journey. And then after this survey, we're just going to jump into the presentation itself. So it seems like, again, privacy enhancing technologies, most people have heard a little bit about it, but nobody is an expert, which is all good. We will cover a lot of that in the coming sessions. So, uh, as I said, lots of sessions coming up, and we will jump directly into it. Now, first, let's align on the why. The reason for doing all these office hours is so all of you can have a great hackathon experience. That is the first motive. And we want to lay the foundation for you to all become expert data scientists in the future. And you should be able to extract insights from the data without compromising the privacy of individuals or institutions. That's the purpose of the privacy enhancing technologies track in the UN Datathon. And today we will be looking at what are the various types of machine learning frameworks and what are the components of a machine learning pipeline. Now, a quick intro of myself. I am a product lead at Oblivious. I'm based in London right now. My background is in machine learning. I did a PhD in machine learning from University of Oxford, and since then I have been in various cloud-focused and SaaS-focused startups. So quickly answering the question in the chat, the Monday session materials have not been posted on the UN Datathon website yet. I need to send the full video to Clarence, so that's on me. Hopefully they will go up either today or tomorrow. Okay, so here are resources. You'll also be able to get these slides when the session goes online, but I curated a quick list of resources, things that I will chat about in the rest of the talk itself, but also things you can draw upon in the rest of your time as you prepare for the hackathon. So I wanted to put together a quick resource list for you guys for the future as well. These are mostly things to get you introduced and started, but also a lot of it draws from scikit-learn, which is an excellent resource for all machine learning and data scientists. Now, the first thing we need to think of when we start thinking about machine learning models is what are we trying to do? And so the way to really start making sense of the world of machine learning models is to think very clearly of the task you are trying to do. And we'll look at a few types of tasks. But then once you have identified that task, then you can start looking at what are the requirements of your data set, what kind of processing you need to do in kind of a model, and what kind of math representation might be good for your particular task and your data set based on the model you have chosen. Once we have these four pieces in place, we can start making sense of the complete landscape of machine learning and data science models we see. Because I'm very aware that the field of machine learning is moving very fast. It's very hard to keep up with every new model that is kind of coming out every day. So that's why it's important to remember what are you trying to do, and then that way you can see and understand the full breadth of the world of machine learning. And here is how all of that splits down. Now, focusing first on the tasks themselves. There are a lot of different ways you can cut this, but one expression I found really helpful is cutting it down into these 7 categories of tasks. And they fall in regression, classification, clustering, association rules learning, decision making, blind source separation, and dimensionality reduction. Today, we are going to go into a few of them, which I think are the most relevant for the UN Datathon. And then I'll leave the rest up for you to explore in your own time from the resource links that I put up at the beginning. In dataset requirements, again, the kind of thing you want to do with the dataset and the type of dataset that you have, you can do supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. There are now a few different things that are additional here that have been unlocked by the world of kind of generative AI, but they broadly still fall into these categories. And just to flag which ones are going to be, in my mind, the most important for you for the UN Datathon are these ones that I've highlighted in red. Just quickly looking at the tasks, these tasks, I think, lend themselves most well to the kind of data sets that are broadly available in the Datathon. And these kind of tasks are also pretty manageable in the kind of timeline that you have in the Datathon. We have a few other joiners. I'm just adding them. So I'll briefly pause there. Any questions from people in the audience? And as I said, you can easily go to the Slido and you can pop your questions there as well. And that way we can see throughout the chat like new questions coming in. Okay. If at any point want to ask a question, please just raise your hand and I'll keep an eye out for that as well. Now, first we are going to look at these tasks. I'm going to focus on the top three. And the first one of those is regression. I think you might all be fairly familiar with these, but I'm just giving a quick overview on these again. In regression, the task is usually to find the value of a property based on the other features you have within the data set. Most often, regression tasks are good for continuous variables, and they are usually used in forecasting some value of the future. You can think of when people think stock market prediction, that's a regression task. When people think how much rainfall might happen in a particular location, that's a regression task. When people are thinking about some kind of evolution of like land use or like household incomes, these are all examples of regression tasks because continuous numbers are involved. And then they can, obviously forecasting is one of the big applications, but filling in missing values in the data also works very well with regression tasks. And regression is something that even when you have a data set, you can use regression on your data set to come up with a slightly smoother, slightly cleaner version of your data set. And we'll come back to this in a second when we look at the data science pipeline. Now, the second type of task that is super useful to remember for the Datathon is classification. And classification basically takes the data you have and tries to put it into buckets of classes that either you know that the data has, you know which kind of classes the data has, or you might have received from somebody that this data set should be divided into these classes. And classification is a form of supervised learning. We'll see what supervised learning is in a second, but basically it tries to find a boundary between things. Very famous, obviously, a classification type is like, cats versus dog pictures, or classifying different types of households into different kinds of categories, classifying crop yields, classifying disaster zones. There are so many different types of classification tasks that you can do. And I think classification, given that the focus of the Datathon is so much on geocoded data, classification is really probably going to be one of the tasks we will see a lot in this Datathon. Then is clustering. And I want to make sure that I really draw out the difference between clustering and classification, because on the surface of it, they look very similar. The main difference in clustering and classification is supervised versus unsupervised. Usually in classification tasks, you have an understanding of what kind of classes exist in the data, and you want the machine learning algorithm to find those classes and tag what it sees belongs in what class. Clustering is slightly more open-ended. Clustering is an unsupervised task. You don't necessarily know how many kind of clusters exist in the data set, and actually what maybe might be the features of those clusters even. So that there is something where clustering is a more open-ended task. So I think for more advanced machine learning participants in the Datathon, clustering type tasks or clustering type objective functions would be very interesting to explore, given the wealth of geocoded geotag data sets that we are getting this time. Now, again, on this picture, now we are going to look at the supervised and unsupervised learning aspect, which I briefly touched on. Supervised learning basically is when your data is labeled, when you have some aspects of the data that are already clearly marked on what they are. And here, obviously, you have these pictures, but they are already marked as dog and cat, etc. And then you can give your machine learning algorithm a new picture, and you can ask, is it a dog or a cat? And in this, the data set has to be labeled either by computers or either by humans. And the supervised learning tasks can only be done if your data set has some kind of labels that the algorithm can learn from. This obviously is in contrast to an unsupervised learning task where there are no labeled instances. You kind of rely on the machine learning algorithm itself to understand what might be the underlying truth. And so, for example, here, it's the same data set, but we don't have any cat or dog labels. We just, the machine learning algorithm will just kind of infer what might be the natural clusters that this task should have or could have, and then it tries to put the data in those buckets. Now, for example, on surface level, it might be that the algorithm is just trying to differentiate dog versus cat pictures, but it might just as well be some kind of geography of pets. Like these are the pets of people from Asia. These are the pets of people from Europe. It could be something like that. So, and we don't know because the algorithm has obviously just tried to make the best sense of the data, and it has just then applied that logic. So it's important when you do unsupervised learning to try and make sense of why did the algorithm do what it did. So just a quick, again, to show this diagram, that the thing we have covered so far is how can we put several kinds of machine learning models that we see out there into a systematic approach of what are they going to be good for. So now let's say you are in the Datathon, you want to do really well. Where should you start? First, I think you should start with looking at the various data sets that you have available and narrowing it down to a kind of task that you are interested in doing on that data set. Given these 7 or so classes of potential tasks I have shown you here, I think you can choose one of them. The ones highlighted in red, I think, are the ones that are possibly the best match for the current data sets, but the other ones are still very valid tasks that you can go after in the Datathon. And the reason I haven't marked them in red is because I personally think they're a little bit more advanced tasks, and it may be that you will need more time than maybe the Datathon allows to go for that. But by all means, you can attempt them, and they still make for many interesting challenges. So we have a quick question. So is random forest algorithm, can it be used both for classification and regression? If yes, can I provide some examples? I would say that yes, random forest can be used for both tasks. Most of the time, like it's a really great algorithm for clustering. it's a really good algorithm for classification. So usually, like as a classifier, random forest will be like your first port of call in most of the things you do. Random forest can also be used well for forecasting, but I personally probably would use other things in regression before like checking that. Now, to give examples, I'll draw back actually from a data science project that I did a couple of years ago. So we were, and this actually is like an interesting example of a kind of task you can also do in the UN Datathon. So we had access to a large scale data set from a city government that was trying to understand how to assess water main breaks. So they basically were a city government who wanted to make sure that the budget they were spending could be spent better. And they realized that maybe if they proactively fixed pipes that needed maintenance, then those pipes of water that were supplying water to the whole city will not burst or explode, because exploded pipes needed way more money to be spent to repair them than a pipe that was just like maybe hasn't burst, but just could use some repair. So they wanted to predict where they could go for their next maintenance tasks and ideally repair the pipes that were most in danger of bursting. And so there we took the data which had things like the life of the pipe, when was the pipe last repaired, what was the material of the pipe, where the pipe was located, in which area, other attributes like the size, etc. The weather conditions, we were able to overlay like what are the temperature ups and downs, because this was a location that used to receive rainfall and snowfall a lot. So by layering those multiple types of information in the data set, then we put that through random forest, and then random forest could cluster or classify the pipe breaks by kind of risk that of breaking in the next few years. But of course, this was a supervised learning challenge because we had data on which pipes had burst, what were their characteristics at the time when they burst, and so by feeding the algorithm all of those supervised data information from the past, we were able to use it to forecast the future. Hopefully, Tabiti, this provides you some idea of like an example of where you can use a random forest algorithm. Great. So moving on, I now want to turn the attention towards components of a machine learning pipeline. And a machine learning pipeline, I think, is something that, like a data science pipeline or a machine learning pipeline, is a systematic way of setting up your data science project so that it can do reproducibly recreate the results that you are getting. And this is tied to something that I mentioned in the last presentation, just to quickly remind you. Oh, it has signed me out from the account. Please give me 1 second. Okay. Sorry for the interruption, guys. I didn't realize I'd been signed out from this. All right, I think we are back on track. So these are the 5 principles of responsible data science. And by structuring your project in a data science pipeline, you make sure that you can adhere to these principles, and you can make sure that at each point you will be able to follow the best practices. The 5 principles we talked about is that your data science project should not have unintended harm. It should not have harms of negligence or any oversight. It should be fair. It should be basically making sure it has equal representation. It ensures just outcomes. It has transparency. It has accountability, and it has privacy. And to make sure that those principles are followed, we structure our projects in a way that makes each part of it correctable and structures it in a way where we can debug each part of the pipeline as well. So the 3 key parts of the machine learning or data science pipeline is preparing the data, building and training the models, and deploying the models, and predicting and forecasting or completing the task that you designed the pipeline for. The first part is preparing the data. This is potentially the place where you might be spending most of the time initially to prepare your data into a format that it works nicely with the rest of your pipeline. The preparation of the data has 3 key steps. You have to understand how you are linking with the data storage locations. Are you using a proxy? Are you like downloading the data somewhere? Are you creating your own database? Then there is data ingestion, taking the kind of raw files or the format that you have received the data in and putting that into a format or a structure that works with the rest of your pipeline so that, for example, the data ingestion might mean putting it all in one database, putting it all in a CSV, putting it all in a format which is accessible for the rest of your pipeline. Then, once you have all that data in place, you do data preparation. Data preparation has a few things which are mentioned here. There are a few others as well, which you can deep dive online on. But the main things are normalization, transformation, and validation. You want to make sure that your data has valid entries. It's not giving you nans or zeros or kind of garbage values. And so making sure that the data ingestion process has gone well. This is the validation is the first part, making sure there is data integrity. Then the second part in normalization is around making sure that the data does not have extreme values, chopping out certain values that maybe are skewing your data. So you need to explore your data at this point a little, take out some values that are completely out of whack or do not follow some of the parameters that you are really interested in looking at. Removing outliers. So there might be some data values that are not extreme values, but they just are maybe not the relevant for your question. For example, if you are looking at a 10-year data set of some geography, but for 1 month out of those 10 years, that location maybe had extreme rainfall. And that hasn't happened since. That only happened for 1 month out of 10 years. But those rainfall values are just very extreme. And so you can take them out as outliers and leave the rest of the 10-year data in there. Then another part is converting your data into ranges that are more manageable to manipulate. So for example, maybe you have all the values in a particular data column in millions or billions. Then you may want to convert those values because doing calculations or millions or billions may at some point like throw out your data calculations and you may run into rounding errors or math errors that you may run into. So you may want to convert it into a smaller number of decimal points, or you may want to convert, for example, a range that is in centigrade into Fahrenheit, like depending on which geography you're dealing with. And similarly, making sure that the data has a consistent format throughout is also really important at this point, because you may see that like if you're getting data from multiple geographies, it may have multiple currencies in it, it may have multiple temperature scales in it, it may have different length scales in it. So making sure that you're converting all of those things into the same scales, the same measures, the same currencies, the same kilometers, meters, etc., to make sure that any values or learnings you are getting out are valid. Then is feature development. And I think feature development is personally my most area that I find most interesting. And actually, feature development is the thing that is going to give you the biggest boost in model performance throughout. And I think, given that the Datathon is only 72 hours, possibly I would say that you should be spending a good 6 hours of the datathon really crafting good features in your model. The usual tendency as data scientists is, oh, I want to try out this whole new fancy model that I read about today in some blog. But I would almost say that in a hackathon, feature engineering can give you a better chance of success than just trying a new model. And I can speak a lot more about feature engineering in the Q&A. What is feature engineering for maybe somebody who is not aware? So feature engineering is basically creating new features from the data set. You have a given data set, it will have certain columns, but you can create new features out of the data set. For example, most of you will be aware of maybe BMI, the body mass index. And body mass index is actually a new feature that is calculated based on people's age, based on people's heights, and based on people's weights. And so using those three numbers, you can create a new feature called BMI, which helps you do something. And similarly, so basically feature engineering combines data from a few different columns, creates a new column, or it converts continuous variables into ranges. So maybe you have some data that is people's income, and it goes from 0 to 1,000. You can leave it as a continuous variable, but you can actually create an additional variable out of it. You can range it. You can say low, medium, high income, and you have now just created a new categorical variable out of your data set, which takes the same continuous data you had into a new range. You can also transform columns into a new way. So for example, if you have data which is really exponential, you can, instead of just using the values as is, you can take the log of the data, for example, and convert it into a different range. Or you can multiply it or scale it up or down. Or you can take the ratio of two different columns. And all of these things will generate new columns in the data, which when you use something like a random forest classifier or any of the other models in scikit-learn or keras or pytorch, you'll get more value, because then the machine learning algorithm has so much more information to use in making these downstream decisions. Then the second part, which maybe is the thing we think of when we think, oh, machine learning, is building and training the models. What is this? So when you in the current day and age, most of the time, especially in a hackathon, you don't have to create a model from scratch. You usually should be using some libraries which have existing model frameworks. You should be using scikit-learn or keras or tensorflow or pytorch. If you are familiar with whichever one of these, you should be using that library. If you're a complete beginner, I think scikit-learn is the most friendly one for people to get started with, and probably the one that has a very long-standing documentation and plays very nicely with a lot of the other libraries in the Python ecosystem. Of course, the underlying thing maybe I'm assuming here is that you're working in Python. If you're working in R, I'm really sorry, I don't have much advice for you, because it's not a language I work in a lot, so I mostly work in Python. If you're really interested in upping your machine learning skills and trying really, really state-of-the-art models, I think Hugging Face is an extremely amazing resource for you to take pre-trained models and add your data to it and see what new things you can do with it. So I think Hugging Face would also be a great resource if you are a more advanced science student, or you have a lot of experience in data science but want to transition to machine learning. I think Hugging Face is a great stepping stone for you to just like try new out of the box models with the data. Now, in the kind of this phase, there are still, even when you take these models, there are a few steps that you have to follow. Obviously, once you have the data, you then need to train your model on this data. Training the model actually is about tuning the hyperparameters of the model. The model needs to find which values work for your particular data set. And then another advanced kind of technique that I think I would encourage all of you to try, no matter which stage you're at, is model selection. You can kind of code your Python framework to pick between a few different models. So you can take random forest classifier, naive Bayes classifier. You can take like bucketed approaches and give it an option of 3 or 4 models and train all those models on your data. And then you can see how they are performing, and then you can allow your pipeline to pick between the model that does the best, and you can automate all of this across all your runs of the data set. And so this also covers kind of model testing and model validation, which are basically all approaches to understanding which models are the right fit for you, which flavor of the model is the right fit for you, which kind of hyper parameters should you turn on or off, how many layers should you have, how many depth your random forest classifier should have, or your random forest trees should have, how many trees should you have in your forest. All of these are the things that you will need to choose in this part of the pipeline by trying out various schemes and values for those parameters. Then finally, we have deploying and predicting. I think this will be less relevant for the hackathon itself, because this is a part of the pipeline that really comes when you're doing enterprise tasks, when you're doing model deployment in the field. But it's just something to be aware of, because as during the life cycle of machine learning models, maybe your data will slowly evolve and your pipeline needs to be cognizant of such changes and needs to respond to such changes. So this last part is usually about how can you keep running the pipeline, updating the models, updating the model type, tuning the hyperparameters in response to new changes, new formats, more data coming in, etc. So I believe that is all I have. I can deep dive on certain sections, but I would love to respond to questions and leave the floor open for you guys to ask. The intended purpose, of course, of the session is giving you an overview on the models. Tomorrow, we will do a very hands-on fundamentals of differential privacy machine learning, and we'll go through a full notebook, and hopefully you will do hands-on coding with us in that session. So if you like want to come and join us, like please join us. We'll do an hour of coding and really understand how to do all of these steps of the pipeline in a hands-on way. Hopefully this overview was helpful. Now I'll leave the session open to questions. Please feel free to unmute yourself and ask a question if you have. Yeah, sure. Could you elaborate on how to start using Hugging Face? Yeah, actually. So if you're just starting out, I have this link that I left. Basically, Hugging Face docs are amazing. They help you through it. But here they list all the model libraries that they have, and you can go and pick a few models to test out, and they will give you an instruction of how to add your own data, how to get started on it. It's a really beginner-friendly resource. I would almost say you don't really need to be an advanced level person for Hugging Face. I mean, let me maybe open the Hugging Face website here and we can see like together some of the things. So while that loads, but main takeaway is that uh, in Hugging Face in the docs there are many beginner friendly tutorials that you should try out. There is like an amazing community around it, which you can constantly ask questions. So I would almost say that like probably if you are very new to machine learning, you can start now over the next week or so, try out various different approaches, get comfortable with it, so that while you're in the hackathon itself, you have identified some of your favorite things, favorite models, discussed it with your team, which things are appealing. And the Hugging Face also has like a lot of data sets for you to try your techniques on. And so like, yeah, I cannot recommend it enough. there's another question. So among components of machine learning pipelines, which one we should spend more time on? Yeah, actually, it's a really great question. I would say that I think for the Datathon, probably spending the most time on the feature development is going to be the most important thing, because the rest everybody has access to, everybody will have access to the data sources that you're looking at, because we're encouraging public data set use. Everybody should have this access to these same libraries. But really, where the differentiator will come is how are different people cleaning and joining the features of each data set, because two people can really make or break by just making different features from the data. And that, I think, you should be spending most of the time in your hackathon doing that. So if, like, for example, if we think like, okay, it's a 3-day hackathon, I think you should spend half a day on ingesting the data, making sure it's in a format or library or a database that everybody in your team can access. Fixing that in the first half day would be paramount. Then I think you should really use the next full day on normalizing, transforming, feature engineering, coming up with cool features for your data set. It's seeing where you can add other data sets to layer on more features. So for example, if you're looking at a city or an urban data set, you can layer on weather data, you can layer on transport systems data, you can layer on housing prices data. There are so many public data sets you can layer on, and they are all part of feature engineering. And then finally, you should be basically spending time on trying out the different models. But personally, I don't think that you need to come up with a new machine learning model. You should be looking at existing machine learning models from scikit-learn and tweaking the parameters. And you should spend a day on that. And I think the final half day you should spend on documenting everything and making a presentable, reproducible notebook or a submission. Yes, I will definitely share the slides for this session, and they will also go up on the wiki. I will, yeah, I think probably everybody with the link will be able to access them. So I will just see anyone with the link can be a viewer. All right. So yeah, you have the slides now as well, DSG. Any more questions? I'm happy to talk more about any of these. If you want, I would love to see like how many people for whom or who are in the call, like for how many is this the first hackathon or datathon that they're doing? If you just raise your hand in the chat, I would love to see if there are like very, very new people. Okay, TSG, it's your first. While you raise your hands, there's also another question we have received on Slido. So tomorrow's models will be worked on just Jupyter Notebook. So actually, yeah, they will be on a Google Colab notebook. So you don't even have to install anything. You can just like you can follow it along in a browser. You don't need to prepare your machine for anything. That's the beauty of the current data science. You can do everything in a web browser. You don't need to worry about installing anything. Awesome. So it seems like at least 3 people have raised their hand for whom it's their first hackathon. And I'm happy to share actually a few thoughts. So I did a lot of hackathons lately as well. And so important things to prepare are make sure that the team that you're working with um, has a good experience, that you all have the time and space to actually focus on the datathon, that your team does not have other commitments, because it can be a very frustrating experience if like the people are doing other things and you want to really win the hackathon. So I would definitely encourage to make sure that like you ask your team to block out the time. The second thing I would say is preparing beforehand, because obviously a lot of the data sets that will be released or shown in the datathon are public, or examples of them are already public. So you should start looking into them. And I think you should start framing what kind of question are you going to try and answer. And I think you should make it such a question that is going to be interesting, of course, for the Datathon itself. But I think ideally it also ties into something you are passionate about, or you is really interesting for you, either personally or professionally, because I think then you will get a lot more value out of doing the hackathon experience over the 3 days, if you finally kind of feel like you made some progress in a professional or personal capacity in the hackathon. Then third thing I would say is, please go and start practicing some of these examples that I've given. You can go on the scikit-learn website. There are many beginner projects there. You can look at the anti-granular website. There are many notebooks there. I can quickly show that as well. And basically, you should go to Hugging Face website. There are so many data sets, projects there. And just start with the most one that is friendly for you. You don't have to invent a new neural network today. Like, don't try to worry that like, oh, I need to be the world authority on this. Just try to have fun, one step at a time. Of course, at one point, it was also my first time doing some machine learning, but obviously over the years you do it, and then you learn more. So as I showed Hugging Face already, I can show also on anti-granular. You have lots of data sets and notebooks, and what I was basically saying, like, you can literally go open the one of the notebooks, and like, it's so simple these days to try things out that then I'll just quickly log in here. But basically you can just port your notebooks, and you can copy them, and you can run them in the browser itself. And you don't need to install anything on your personal machine. You don't need to have a GPU. You don't need to have an extremely expensive CPU or nothing. Anything you can use on a browser, you are good. So here, like as I was saying, in the notebook, you can just go click on any notebook, and you can just launch that notebook, and it will give you an option if it like you open in Google Colab. And so I'll just open it in Google Colab, and it will already show me a pre-populated notebook. Yeah, so already I haven't written one single line of code here, and the notebook is ready, and actually I can just start running it. And all of this means that like I don't have to worry about my machine performance. Any other questions? Also, I might have missed this point, but could you talk how we'll be using pets as tools, or is this not part of the webinars? So actually, yes, we will be sharing that in the webinars. I can give you the quick answer on this as well. So privacy enhancing technologies is a general term for a lot of the different types of tools, techniques, libraries that exist. I gave a brief refresher of this yesterday. I'll just bring that slide up for everybody. So in privacy enhancing technologies, there are many different types of privacy enhancing technologies you can have. In this hackathon, we are going to use two particular types. We are going to use secure enclaves, and you're going to use private Python, which is a particular flavor of Python. And by just using these commands, you don't have to learn anything new. You will use it the same way you use normal Python. You'll just add some little magics to it. We'll go in this in much more depth tomorrow. So here I'll show, like, we'll use this anti-granular package, which is private Python, and you will then use it as normal. You will not need to learn anything from scratch. And by just implementing normal Python code, you will be doing privacy enhancing technologies based data science. So that's why I think this track is really fun, because you don't have to learn anything new or any new tools because there's only one week. Is there a particular type of regression model we should focus on? Honestly, it depends, Luis. If you could give me a bit more context, like, are you beginner, are you advanced, and then I can give you a bit more flavor on what you should do actually. Like, have you used regression models before? or are you, is this kind of your first time using regression? Okay. I don't know if Lewis is still online, but I'll just go ahead. So if you're a beginner, I think like you should mostly use the kind of pre-existing regression tools that exist in scikit-learn. Yeah, I mean, basically linear regression will get you very far. So I think like in any machine learning task, okay, I will come to your question. So in any machine learning or data science task, I think a few things you should do in the hygiene part. One, just try what does all zeros or all ones as a potential answer yield to you, right? Like you can see if something is valuable as a machine learning algorithm, if it performs better than some kind of baseline. What happens if you just predicted all zeros or if you predicted all ones? Like if it gives you 50% accuracy anyway, then like you maybe need to think that you don't need something very, very fancy. And fancy things can be harder to debug. Then secondly, I think within scikit-learn, you can take linear regression very far because it can allow you to add multiple terms in your linear regression and take it more farther. You can obviously try different flavors of regression in the same scikit library just by changing a few words. So I don't think that we need to become very fancy. We can get a lot of juice out of basic important things. Um, so now some other questions. Let me see. So Moz, your question is, where could we find data sets like that we will be provided in the Datathon? Really excellent question. So let me bring this up. So let me find my, I'll open my presentation, which I gave in the last webinar, and I will open that. While I open that, I'll answer another question. So let's see. Will you use AWS APIs directly here? So actually in this track of the hackathon, in the pets track, you don't actually need to do any AWS coding yourself because the private Python library takes care of it in the background. So we have made it really beginner friendly because of course, you can structure AWS APIs, and if you're an advanced user, I would encourage you because you can pull data in any normal fashion, the same way you will pull data in Python from an AWS API, you can for sure do it. But in the example tomorrow, we are just going to show you a preloaded data set, which will be the case in the main Datathon itself. You will get a preloaded data set. So you don't necessarily need to call something from AWS. But if you want to use other data sets beyond the ones that will already come preloaded in the pets track, you can call AWS from within the Google Colab or Python environment that you're using. But it's not necessary, it won't hold you back. I think we have one more question. Is there any resources you can share to look behind the curtain of this module just to understand how it works? Yes, certainly. So for the docs themselves, I would like for now, I would like this is all also going on the wiki. But if you go on antigranular.com, the docs help you with everything. So two parts on the blog, you can see understanding differential privacy and non-technical introduction. And then secondly, you can go to the docs and actually look at the core concepts. You can look at the specific packages in private Python, and that will kind of help you understand a bit more theoretical aspects of this. And then again, like you can keep deep diving in the docs as far as you want to go. Hopefully that answered whoever's question it was. I can provide more clarity. Just also aware we are almost coming to the end of the session actually. If you have any further questions, you can email me. I will be here again for the Friday session. Tomorrow's session will be given by Jack, who wrote a lot of the libraries in Antigranular. So He will also be able to give you a great flavor of differential privacy. If you have other follow-up questions, you can message me on ali@oblivious.ai. Where will we deploy this? So in terms of deployment, but Martin, if you can maybe add a bit more flavor to your question, like what do you mean by deploying? Like for the Datathon, like where would you need to deploy the model or what? In yeah, okay. So the model deployment, you will use the Python environment that you have already online, the Google Colab you will use, or uh, whichever Python environment you want to use. You can just deploy it. Gets deployed online. You don't have to set up any infrastructure yourself for deploying the machine learning models. In the context of the Datathon, for example, how it will work is that there will be a preloaded data set in the Datathon for the pets track. You will go in, you will get a code or link, your security credentials. When you input them, you will be able to access that data set. And then you can just call that data set in your Google Notebook or your Python Notebook or Jupyter Notebook, whatever version you're using. You'll just be able to make queries on that data set, and you can develop the machine learning model using scikit-learn or the various tools we have said, and then you can easily share that code as the result of the Datathon. So you don't have to have it up and running anywhere. The backend infrastructure takes care of that. That once you have written out all your code, you can show us some results. Of course, in the final presentation that you show, you can show that here are the charts, here are the insights, here are some things we found as a team. So you can put all of that in your final presentation. But when you will submit your notebook or the code, we will be able to check and run that in the background itself. So you don't need to hold or deploy it anywhere. You don't need to have any website running or a AWS instance continuously running, at least for the pets track. I'm specifically talking about the pets track. I'm not speaking for the other kind of tech partners here, obviously. Yeah. So yes, your question. So for the data set, there are two sources. Actually, I would say that you can, if you just search online for microdata library, then you will find both of the resources I'm suggesting. One is the World Bank microdata library, and then the other one is the UNHCR microdata library. And these are the data libraries that are most similar to the kind of data set you will receive in the PETS track. So because in the PETS track, we also have microdata coming from a UN body, and that would be disclosed, I think, tomorrow will be revealed this data set. And if you want to start, but you won't have access to the data set tomorrow. But if you want to start practicing, you can start looking at these two microdata libraries. I think why allowing AWS access? So maybe I don't fully understand your question, but I'll give kind of some the main answer I can understand. So because the Datathon has many tracks, it has the kind of the full Datathon has different tech partners, AWS, Esri, like NetApp, and Oblivious, of course. So there are many paths in the Datathon, and I'm particularly talking about the pets track. And for the pets track, obviously, we have also provided the tools and APIs that you use in the pets track. And in the pets track, you don't need any specific thing you need to spin up on AWS. But if you're participating in the broader hackathon, you're not in the pets track, you can use AWS. You'll obviously need to set up the environments or use the Jupyter Notebook, etc., in the AWS environment. But for the pets track, there is no need to set that up. We take care for you in the backend because we automatically set up a Nitro enclave in the track. When will the team choose their track? So actually, the track, if you don't have a deadline for choosing your track, and the same submission can be considered for multiple tracks. So maybe you create a thing and it will be considered for the general, but if you use the privacy enhancing technologies tools that we are providing, then your submission automatically gets checked for the pets track as well. So you don't have a one or the other, you can make one submission and it can be considered for all the tracks as long as you're using the right technologies in that. So For the pets track, obviously, we have a particular data set and these particular tools, but the same submission will be considered for general judgment as well. And there is no deadline. You can, until end of the hackathon, you have this choice. I know we are kind of running a little bit over time now, so any final questions from anybody, I'm happy to answer. Other than that, again, we'll remind everybody we'll be here again tomorrow, and we will do some very hands-on coding tomorrow together in this session on differentially private machine learning.
Hey, Ali, it's Clarence. Can
Hi,
I just come in
Clarence.
for a sec? Yeah, I actually had a question.
Sure.
Do you know yet how we'll be distributing the credentials? Just to follow Elizabeth's question.
Yeah, absolutely. And so actually what will happen is that the teams that have registered will create their single sign-on ID, and then everybody either later this week or next week will get an email saying that, hey, your ID has been created. You'll be able to go on antigranular.com because that's where the data will be hosted. So there you will see a dataset section, and here is where the UN dataset will show when the
Okay,
hackathon goes live. And then you will click on that dataset, and here is where your team's credentials will be showing when you'll be logged in with your team
okay,
ID.
great. And that's the single sign-on that Sean is setting up with the UN Global platform, right?
That's right. Yeah.
Okay, perfect. That's great. Thank you so much.
No worries.
Yeah.
Yeah, so these will be the credentials, and you'll just be able to copy them. And actually, when you will go into your notebook and you will paste those credentials. So for example, here, this is where the credentials go in this notebook. So when I paste them, you can see that it suddenly replaced those with actual key values that I will use in this session. And I am not worried about showing you this because these session IDs will get recreated for every session you do. So that makes it really secure. So you'll just go there in the UN data section, you'll copy this, you'll paste this in your notebook, and you will have access to the data set. Any other questions, friends? Otherwise, I am happy to wrap up this session, and hopefully I'll see some of you tomorrow. Mateen, the slides and the video recording, yes, it will be shared on the wiki, and it will be on the UN Datathon YouTube channel as well. Could you share the link where I can find it? Oh, just Pets Track, could you share the link where I can find the details? Yes, the wiki will go live after tomorrow's webinar, and that's where you will see the links to the Pets Track and everything. I'm right now editing the wiki. So Clarence, this is also a shout out to you. The wiki will have more information shortly.
Thank you.
Awesome. Awesome, guys.
All right. See you
I
tomorrow.
think awesome. See you
Yep.
everyone tomorrow. Have a lovely day. Bye-bye.
Thank you. Bye.
Thanks.